Hello, my viewers. My name is Young Sunday, and I welcome you all to this my educative channel about chemistry of PU foam. That is a PU foam or flexible foam or production or process, both continuous and semi-continuous, and that of the batch process. Now, in my presentation today, we shall be looking at why adding pop. Why adding pop? Why adding pop? That is to say, in my subsequent presentation, I did say that the PU foam formulators often blend pop and the pure polyol, and to achieve a certain comfort and the desired physical properties of that foam that they desire and tend to produce. So in the course of doing this, they need to bring in this polymer polyol and add it with the polymeric, and blend it with the polyether polyol to achieve that desired properties. Are we all together? So in this case, the reason is that why do we add it? Why not substitution? Because throughout the old world, okay, let me use Nigeria as an example. In Nigeria, we love hard foam. A typical Nigerian believe that if the foam does not act, it means that mattress is what? Substandard product. But I do not blame them, because they are not in the picture of how this are being processed, but that is what they want. So in the course of increasing and optimize your selling strategy, people tend to develop a formulation that will give them such an hardness for the customer specification. At time in the process of increasing the hardness to impress the customer, the foam, the entire foam physical property is being suffer off. So such foam will not sustain. Now that is the problem. So the manufacturer came out with the idea to produce this, whereby it can be blended with a 100% polymeric polyol to achieve that hardness. Now, what is pop? In a simple terms, what is pop? Straightforward. Let me do this. Look at this. Polymer, that is solid. Okay, polymer solid plus polyol liquid equal to polymer polyol, abbreviated as pop. So this is just the polyol. Okay, polymer solid, and I just said that this solid particles that are dispersed in this polyol, they are non-reactive. Okay, polymer, they do not react, but the percentage of that polyol that remain can react with the other one. So I'm going to show you how it's been formulating. So the question, why do we blend it? One, costing. One is costing, because polymer pop is cheaper than this. Okay, this one undergo full polymerization, while this one do not undergo such polymerization. Therefore, they use a certain part of SA and silane acrylonitrile to replace this, and this one is full. So this one undergo full polymerization with ethylene and propylene oxide, depending on manufacturer specification. So they use it for costing. Two, let me just say this costing in that this solid particle act as fillers, just like we have calcium carbonate too. Okay, so the price of calcium carbonate is far cheaper than that of the polyol. If you are considering the price per kg and use it as strategize your formulation, you see it clearly. You understand? So we use it in a substitution. It's not in addition. Go back to my previous techniques in formulating PU foam. So 100 of polyol mean you substitute 10 part, for example. So you use 10 part of filler to replace, to substitute this one and add this one. So it will still give you 100. That is 10 minus 100 minus 10 equal to 90. So pure polyol is 90. You now bring in this one. You go back to 100. You understand? Now we also have load bearing. Load bearing capacity. Now let me explain this load bearing capacity. You see, flexible polyethylene foam behave like a spring. It has a spring property. Okay, that is how, right from the chemistry, okay, how it been the formulation, from the formulation till the final reaction. It's supposed to behave like spring. That's why they call it flexible. There are other rigid also that are not as flexible. So this one they call it flexible. Remember, all what we are doing here is flexibility we are looking at. So this flexibility means that it can stretch. Okay, so when you leave it just like a rubber, it will return to the original shape. You understand? So when it is subject to load, it will react based on that load. So when it is on load, it will return. So that is the ability. So by bringing pop to it, you are increasing the load bearing properties of that your product. And we are going to see the percentage of medium hardness, full hardness, and semi hardness. All those things is in a presentation in the formulation aspect. We also increase hardness. Okay, it gives us hardness too. Hardness means fairness, and it reduces what we call block shrinkage. That is very, very important. Many people do not know this. Okay, pop in your formulation reduced block shrinkage. How many of you know this? Now, if you are adding pop with the other polyol, you know, foam after curing, the CO2 will leave the system. So some will compress. So there are some polyol. If your formulation is not well balanced, you are going to lose 1 inch around the size of the block. But by using pop will help you maintain it. Okay, though it will shrink, but the percentage of shrinking will be very, very small. That is one of the good advantage of adding pop to your normal polyol. I hope this is very, very interesting. So they are the reason why pop is being often blended by some of the PU formulators, just for those properties that we have mentioned so far. I believe this is well educative. Continue to like my page on your notification so that whenever I upload a new video, you'll be notified. Like the page. Okay, we are going to learn a lot. This is just the beginning about this chemistry of pop in PU foam, because most people do not understand. A lot of people send me questions. That is why I have to take time to address it, so that you understand the difference between pop and normal polyol. Thank you. Bye bye.